Hello, and welcome to our lesson on warehousing and storage equipment. This segment will cover objectives of good warehouse design and management. To minimize system costs while ensuring top-notch customer service, key principles for efficient operations include use of building space, choice of unit load, utilization of resources, minimum movement, control system and information system, product integrity, work safety and conditions, environmental issues, information and communication, packaging and unit loads. Optimizing warehouse space is vital. To achieve this, consider the following. Remove obsolete stock and minimize overall stock holding. Choose suitable handling and storage systems thoughtfully. Maximize space utilization through factors like building height and mezzanine floors. Implement random location systems for a stock organization. Maintaining clear access to stocked products is essential. In warehouse design, a crucial balance lies in maximizing space usage while ensuring unrestricted stock access. A unit load is a grouped assembly of individual packages or products, typically of a similar type, designed to streamline movement, whether done manually or mechanically. Examples include various types of pallets: wooden, post, tote containers, roll cage, steel, or plastic cage, and ISO containers. Efficient use of unit loads offers benefits such as transporting larger quantities per trip, minimizing movements, compatibility with standard storage and handling equipment, stock protection, optimal use of storage space, and smoother coordination between transport and warehousing operations, including truck loading and unloading. The warehouse design and management should enable efficient and effective use of resources, covering the monitoring of equipment utilization and availability. To reduce goods movement, consider the following strategies. Place FMCG high-turnover products near the dispatch area to minimize travel time. Provide handling equipment to reduce manual effort. Utilize computer-based planning for efficient warehouse goods movement routes, minimizing travel time. Separate reverse stock and order picking to concentrate picking in a compact area, preventing bottlenecks. Plan movements to enhance handling equipment and personnel utilization, avoiding empty travels such as dual cycling where handling equipment carries products during both return and outward movements. During warehouse installation, a fast, effective, flexible, and accurate information and communication system should be established. The functionality should cover the following: logging stock movements and maintaining balances, monitoring productivity, the availability and utilization of resources like storage and handling equipment, controlling stock location, tracking the goods movement through the practical system, ideally instantaneous communication between the management system and operators, planning optimum goods movement routes, additionally order picking, sorting order requirements into suitable order picking tasks. The systems of warehousing and handling should be designed and managed so that products can be maintained appropriately for the consumer's customers. This involves systems in place to reduce loss and damage, satisfy stock rotation, and any legal constraints on the storage environment, like temperature limits. Conventionally, the number of warehouses taken has made the function monotonous and arduous. In recent years, this has become an area of growing importance. Some current innovations in truck design, forklift for instance, are mainly aimed at reducing the risk of repetitive strain injury and improving operator environment. Lighting levels, humidity, and hygiene also impact the operator environment and consequently on operators' performance in the long run. There is no doubt that due to the lifting and manual handling of goods involved, safety has prime importance in warehousing operations. In fact, with the levels of automation and mechanization in some advanced installations, safety plays a vital role. The amount of related legislation further highlights this. The awareness of environmental issues is increasing daily, and it is one primary reason that more and more has to be taken into account in the warehouse design and management system. Examples are the regulations affecting packaging, additional responsibility, and the cost forced imposed on suppliers. In essence, warehousing is simple, but it can go spectacularly wrong. The reasons for performance failure are inadequate communication and information systems. A good communication system, information and monitoring system inside the warehouse, and also communication out to the broader supply chain, are essential for effective and efficient warehouse. Without such an appropriate system, in fact, without experienced personnel and well-designed facilities, the overall maximization of the performance of the warehouse will not be accomplished. The definition of packaging covers the art, science, and technology of preparing products for dispatch and sale. Safe delivery of goods is an integral part of an SC, and the use of packaging and design influences not just handling and storage, but also other functions like marketing, manufacturing, and determination of the most suitable type of unit load to be in use. The following are the functions of packaging: to preserve an item from chemical, mechanical, and physical deterioration, contamination, or damage; to contain the goods; to communicate safety instructions, instructions for item use, and other information; to facilitate ease of unitizing, ease of handling, and, in some cases, to act as a dispenser and measure; to act as a marketing aid through presentation and appearance. Unit loads involve placing goods on standardized modules for storage, handling, loading, unloading, and movement. This concept ensures the use of standard equipment, regardless of the type of goods, leading to enhanced security, cost efficiency, space utilization, and reduced material handling. The structure of most physical distribution revolves around unit loads, chosen to optimize the efficiency of the supply chain. Examples of unit loads include wooden pallets with varying standards, such as ISO 1200 mm by 1000 mm in the United Kingdom and 1200 mm by 800 mm in Europe, pose challenges in cross-border movement. Wooden pallets are widely used and come in different configurations, including two-way or four-way fork entry, reversible or non-reversible, and closed or open board. Small galvanized plastic containers like tote bins for handling and storing small parts. Roll cage pallets with dolly cage sides and wheels are commonly used in wholesale grocery distribution systems. Metal box pallets and cages with corner posts for containment are often stackable and suitable for various items. International Standards Organization freight containers with standardized external sizes for efficient stacking, fitting, loading, and unloading during sea and land transport. These containers support secure transit and minimize turnaround times. Intermediate bulk containers, IBCs, are designed for 1-2 tons payloads, bridging the gap between unit load and bulk handling. These containers accommodate solid particulate goods, including building products and chemicals, with options like rigid plastic IBCs, collapsible canvas IBCs for easy return, and low-cost fireboard IBCs for one-time use. IBCs eliminate the need for conventionally sized sacks, and their standardized design allows for bottom emptying, top filling, and handling with standard forklifts. This is the end of this segment of our lesson. In the next segment, we will continue discussing the objectives of good warehouse design and management. This course is presented to you by South Europe College. Thank you for listening, and see you on our next segment.